So registers, a collection of flip-flops taken as an entity. That is, a register is nothing but a simple collections of flip-flops. The basic function of the register is to hold the information within a digital system so as to make it available to the logic elements during the computing process. However, a register may also have additional capabilities also associated with it. A register contains finite number of flip-flops, countable number of flip-flops, okay? And each flip-flop is capable of storing a 0 or a 1 symbol. There are only finite number of 0-1 combinations that can be stored in a registers. Okay, each combination of the stored information is known as the state or content of the register. Okay, shift registers, registers that are capable of moving the information upon the occurrence of a clock signal. The data or the information can move in a single direction or the information can move into a both the directions, okay, right to left or left to right. The data can move in both the direction, that is the bidirectional. So there are the data can move either in a single direction, okay, that is unidirectional. The data can move from right to right or right to left in a both the directions, that is bidirectional. So next, two basic ways in which information.
Excuse me, ma'am.
Yes. Two basic ways in which information can be entered. Okay. The manner in which we are trying to enter the data into the registers and taking the output from the registers. Okay. There are two ways. One is enter the information into the register and to take the data out from the register. Two ways means one is parallel and another one is serial. Parallel means what? All 0-1 symbols handled simultaneously. Means if suppose we have a 4-bit register, shift register, all the 4 datas are available at a single instant of time. Okay, parallelly the data are available at a single instant of time, and if suppose 4-bit register is used, we require 4 lines to represent the data, or for the symbol to store the symbols, 4 symbols, we require 4 lines. Require as many lines as symbols being transferred. Serial means involves a symbol by symbol, that is one symbol by another symbol, availability of the information in a time sequence. It is involves the symbol one by one serially. We try to put the data inside the register and one by one we try to take the data out from the register serially, that is one by one. Okay, so two basic ways in which information can be entered or output. Okay, parallelly we can enter the data. In parallel what happens? If suppose the 3-bit, 4-bit, according to the bits of data, so many lines we require. Serial means 1 bit by bit, so single input is sufficient for serial. In parallel means as many as data bits, those many lines are required for the symbols to be transferred. Next, 4 possible ways register can be transferred, that is serial in, serial out, serial in, parallel out, parallel in, parallel out, and parallel in, serial out. So you can enter the data into the register serially and take the output from the register serially, or you can enter the data serially, take the data out parallelly, or you can enter the data parallelly and take the output also parallelly. Next, here parallel in, serial out. Parallel in means enter the data parallelly, take the data out serially, one by one. Okay, parallel means at a single instant of time all the data symbols are available. Okay, serially means only 1 bit data is available serially, that is symbol by symbol availability of information in a time sequence. So here this is a serial in, serial out, unidirectional shift register. How many bits are there? See, 1, 2, 3, 4. 4 flip-flops are there, isn't it? Here we have serial data in. Here we are trying to enter the data into the register serially. Okay, the output of the first flip-flop is connected as an input to the second flip-flop. The output of the second flip-flop is connected as an input to the third flip-flop. The output of the third flip-flop is connected as an input to the fourth flip-flop, and Q is the serial data out. From the Q we can take the data out. Okay, serially we are trying to enter the data into the register. What is register? Register is a collection of flip-flops. These are flip-flop. Which type of D flip-flop? Which type of flip-flops are used? D flip-flops are used. What is the function of D? It is known as a transparent. Why? If you apply 0, you are getting at the output 0. If you apply 1, you are getting 1. It is just transferring the data, whatever it is at the input, to the output. So it is a very simple flip-flop. We can use this. We have used here positive edge triggered flip-flop. We are using here positive edge triggered flip-flop. What this is? Serial in, serial out, unidirectional shift register, as it is shown in the diagram. Okay, we are using positive edge triggered D flip-flops. The Q output of each flip-flop is connected to the D input of the flip-flop, which is to its right. Okay, the control inputs of all the flip-flops are connected together to a common synchronizing signal, and that is called clock. This is a clock and it is a control signal simultaneously, or it is connected here synchronizing. So, upon the occurrence of the positive edge of the clock signal, the content of each flip-flop is shifted one position to the right. I repeat, upon the occurrence of the positive edge of the clock, the content of the flip-flop is shifted one position to the right. Okay, the content of the leftmost flip-flop after the clock signal depends upon the signal value on the serial data in line. Where is serial data in? Here. The content of this flip-flop depends on the serial data in this line. The content of this flip-flop depends on the serial data in. Okay, and the content of the rightmost flip-flop prior to the clock signal which was there, it is lost. The output from the shift register occurs at the rightmost flip-flop on the serial data out line. Okay, so from here we are taking the output. From here we are giving the input. So upon the occurrence of the positive edge of the clock, the content whatever it is in the serial data line, it is transferred to the Q. This Q is transferred to this D. There it is transferred to this. Then from this flip-flop the data is transferred to this flip-flop. Okay, we are taking the serial data in and serially data out. So the initial content was 1011. So I have written here 1011. Next what happened? I am applying a logic 0 and I apply a positive edge of the clock. This 0 came here. Okay, 0 came. into the first output flip flop. Next the one moved to the next flip flop, this 0 moved to the next flip flop, this one moved to the next flip flop. The last one was there, no, it got lost, the data gets lost of the last flip flop. So now the content becomes 0 1 0 1. In this way the data is serially shifted from one flip flop to the next flip flop, because the data is shifted how? Because the output of the first flip flop is connected as an input to this. Next the output of the second flip flop is connected to this. Next the output of the third flip flop is connected as an input to the fourth flip flop. So we are taking serially in data and serially data out. Okay. So I think now it is clear. Going to the next one, serial in, parallel out, unidirectional shift register. Here serially we are trying to feed the data. We are trying to take the parallelly out. See, QA, QB, QC, QD. Parallelly we can take the output, as many as output so many lines are there. Here serially we are trying to feed. Upon the occurrence of the positive edge of the clock, the output, this data in will come to the output of the flip flop. Next whatever the earlier output was there, it will come into the output of this. Next the content of this flip flop is transferred to this, and the content of the third flip flop is transferred to this upon the occurrence of the positive edge of the clock. In the earlier what we did is we fed the data serially and took the output also serially. But in this what we are trying to do, serially we are trying to feed the data and taking the outputs parallelly. The data moves only from the first flip flop to the last flip flop only in one direction. So it is a unidirectional shift register. Parallelly we are taking the data out. Hence it is known as serial in, parallel out, unidirectional shift register. Serially we are feeding the input, but we are taking the output parallelly. QA, QB, QC, QD. Okay. So next here, parallel in, parallel out, unidirectional shift register. It is also parallel in, parallel out, unidirectional shift register. What is this? We sometimes call this as PIPO also. PIPO means parallel in, parallel out. But here this one, no, it acts as serial in and serial out also. It acts as serial in, parallel out also. Next it also has a function of capability of parallel in. Here IA, IB, IC, ID are parallel in inputs. Next QA, QB, QC, QD are parallel data out. Okay, parallel data in, parallel data out, serial data in and serial data out. So this particular unidirectional shift register can also act as SISO. SISO is serial in, serial out. SIPO, that is serial in, parallel out. Next parallel in, parallel out. Next parallel in, serial out. It also acts as all type, because we are having serial in also, serial out also, parallel data in also and parallel data out also. See here we have two AND gates and a OR gate. The same thing is repeated, two AND gate and one OR gate. Here also two AND gate and one OR gate. Next here also two AND gate and one OR gate. For one of the input here the serial data is there, serial data in here also and here also and here also, and here one more input is load bar slash shift, and for this AND gate we have the output of this NOT gate is connected as one of the input to the lower AND gate, Next, one more parallel input IA is connected. Both the outputs are connected and given to a OR gate. The output of OR gate is connected to D input. Okay. Similarly, QA is given as an input to this serial input. It is serially, because whatever the data is here, after the occurrence of the positive edge clock, it will be transferred to QA and that will be connected to this AND gate. Next, load bar shift is connected here, same thing. Next, for this AND gate, NOT gate output is connected, and for this IB is connected. Similarly, for this serial input and load bar shift is connected. This one, load bar shift inverter is there, that output is connected and the parallel input is connected. Similarly, for this also we have serial input, parallel output, load bar shift output is also connected here. So how does it act now? The operation of this register is controlled by this load bar / shift line. When a logic 0 signal appears on this line, the signals on the parallel data input lines, that is IA, IB, IC, ID, are transferred into the register upon the occurrence of the positive edge of the clock signal. Next, whenever logic 1 is applied to this load bar shift signal, here the D flip-flop becomes a cascade connection and that functions as a unidirectional shift resistor providing the serial output. So parallel in serial conversion of the information. By taking this output individually, we have parallel out. Okay. Serial, it can also be seen that it acts function as serial in parallel out also, and serial in serial out also, parallel in parallel out, and parallel in serial out. It depends on which type of direction or transfer of the information you require. Okay. So whenever load bar shift signal is 0, what happens? The parallel data IA, IB, IC, ID are transferred into the register. Whenever it is 0, the data are transferred into the register upon the occurrence of the positive edge of the clock. Now when logic 1 is applied to this, that time it becomes a cascade connection. You can take either parallelly out or you can take serially out. Okay. So here this AND gate is used for serial data in, this AND gate is used for parallel data in. Load bar shift is 1 means it is connected here. So serially the data is transferred. If load bar shift is 0, then the parallel data is shifted. So parallel data means at a single clock instant of time you get the input and the output also. Serially means first you wait for first clock pulse, second clock pulse, third clock pulse and fourth clock pulse. So the data will be ready at the serial data out after the occurrence of the fourth positive edge of the D flip-flop. Okay. So now this one, it acts as a parallel in parallel out, serial in serial out, serial in parallel out and parallel in parallel out. Okay. So it acts as all 4 type of serial shift, parallel shift also in the input, entering the input also, taking the output also from the shift register. Universal shift register. So this is a symbol and we have a multiplexers here, 4:1 multiplexer. If there are 4:1 multiplexer means 2 select lines will be there, S1, S0, S1, S0. If both are 0, it will hold the data. Okay, how it will hold the data? See, both are 0, 0. I0 is connected to the QA. So it will hold the data. I0 is connected to, this is I0 of the second multiplexer is connected to QB. It will hold the data. Next, this I0 of the third multiplexer data. So this will be hold the data like this here. I naught, whatever data is there, it will go to the F. F, it will go to this D. D, then Q. Upon the occurrence of the positive edge of the clock pulse, it will go. The content of the D will be transferred to the Q output. This will be again gone, and then it is connected to I naught. Okay. In this way, in the circular way, it will hold the data. Okay. Next, if select line is 0, 1, it will shift right. Okay. How it is? See here, 0, 1 means I1 is selected. I1 is having serial input for shift right. SIR, serial input for shift right. So I1 data is selected, it is goes to F and the output is gone to here. Okay. So here it will be shifted right. So next the output is gone here, next right. So here next the I1 is connected to this, and next we have I2. So I2 is here, I2 is there. 1 0 means shift left, 1 1 means parallel load. So whenever we are having 1 1, what happens here? 1 1, it is parallel load. You can see here 1 1. When the select lines are 1 1, it is parallel load. IA, IB, IC, ID. Okay. So here, whenever we have I naught, select lines are 0 0, it will hold the data. This is data. Okay, 0 0 means I naught is selected, so it will hold the data. I naught will go here, D it will sit here, and then transferred here. It will hold the data. Similarly, for the next flip flops. Next I1 means it will shift the data. I1 here. Okay. So here it will shift right. So the output of this QA is connected as an input to this I1 of the next multiplexer. So next again F will go to the D, QB will be connected to the I1. So the data will come here. Next it will go through F. Next D it will transfer to Q. Next again the QC is connected here to the I1, and then it is again shifted to the QD. So it will shift right. Okay. Now next when it is 1 0, it will shift left. See here, this one, whenever it is 1 0, it will shift left. That is 1 0 means I2 is selected. Serial input for shift left, SIL. So I2, so here it will go to D. I2 is selected here. That will be transferred to the F. F is connected to the D. Then the data is transferred to the Q upon the occurrence of the positive edge of the clock pulse. And then again QD is connected back to the I2 of the second multiplexer from the left, and then again I2 data is selected because select line is 1 0. I2 is selected, F will go to the D, and then D is transferred to the Q upon the occurrence of the positive edge of the clock, and then QC is again connected back to the I2, and then again it is output F is connected to D, then Q, and again this QB is connected to the I2, and then F it will go, then it will provide the output QA. Okay. So any doubts in this? So say here there are 4 multiplexer. If it is 0 0, I naught 1 data line will be selected and it will hold the data. If it is 0 1, the data is shifted right. Next, if it is 1 0, the data is shifted left. Next, if it is 1 1, it will parallel load. Okay. Similarly, universal shift register can do different operations, like if it is having 4:1, 0 0 means you can complement the input by putting a NOT gate. 0 1 means you can shift left also. 1 0 means you can shift right also, and various combinations are possible with the universal shift register. It can transfer the data from the right to left or left to right. It can transfer the data in both the directions. So it is known as universal shift register.